Chords, the final frontier. This is the Star Trek theme that features these melodies made out of fourths and so on. We're going to learn about quartal and quintal chords in this lesson on new chord structures. Let's get started. So up to this point, we've largely been dealing with chords that involve stacked thirds or tertian harmonies, like this. Or if we space those out in a different way, it still can be reduced always to stacked thirds. Quartal and quintal chords are based on fourths and fifths instead of thirds. So if I were to do perfect fourths, then I'd have this C chordal chord. Now, this is the next one here. If you use a B natural and an E natural, is much more dissonant. So if your quartal chord has a tritone in it, like this B to F, then it's more dissonant than if it's all perfect fourths. Now, I've also got some chords that are based in fifths, much more open sounding, right? Notice that this quintal chord here is basically the same as the quartal chord that I had at the beginning, but inverted. C, F, B flat, E flat, now E flat, B flat, F, C. So those invert to each other. And the second one here is the same as the inversion of the other one. And you can tell again that that one is more dissonant because it has a B, F tritone in it. Okay, lastly here we see secundal harmonies made up of seconds. Sometimes these are called tone clusters, just bunches of seconds. This first one is all whole steps. The second one's all half steps. You can tell the difference between those two sounds. Now I could also take that A, B, C, D and invert it something like this. That'd be like something like an inverted secundal chord. You can do some of the same things with these types of chords. They're just not based on thirds, they're based on other types of intervals. Now let's look a little bit at the whole tone scale and see what's possible with harmony in the whole tone scale. So of course it only has whole steps in it. So there's no differentiation between whole and half, so there's a limited set of interval types. The only type of triad you can make is an augmented triad. So if I take every other note in a whole tone scale, I get an augmented triad. If I start on D, I'd have, if I start on E, doesn't matter where I start. The only thing that I can get is an augmented triad. This third one here is spelled E, G sharp, C, with that C of course could be a B sharp, making that spelled as an augmented triad. Now if I take all of the pitches from a whole tone scale to create a chord, then I get what we call a whole tone chord. Now if I were to try to reduce that to some type of secundal harmony, I would have C, D, E, and then I have an F sharp, A flat, B flat. So those are all of the pitches from the whole tone scale used in a harmony. Now let's do the same thing with octatonic harmony. As you know, the octatonic scale alternates whole and half steps like this. And because it's another symmetrical scale, it happens that the only type of triad you can create is a diminished triad. So if I take C, E flat, F sharp, or G flat, and then D, F, G sharp, or A flat, and so on, those are all diminished triads. And if I add a seventh to those on any scale degree, the only type of seventh I'm going to get is a fully diminished seventh chord. Alright, so that's an interesting property of these symmetrical scales. There's not a lot of variety in the types of harmonies that you get, which is why we have used diatonic scales so frequently, is that there's a variety of chord types that come from the irregularity of the pattern of whole and half steps. But in these very symmetrical scales, you can only form these specific types of chords. And the octatonic scale has a lot of diminished sounds in it, whereas the whole tone scale has a lot of augmented major sounds in it. Now let's look again at some tertian harmonies, some triads, and see a few interesting things that you can do here. Split third chords are triads that have both a major third and a minor third in them. So here I have D major and D minor, or I could do D minor on the bottom and D major on top. Those would be called split third. In a similar way, we could take two completely separate triads, that is with different roots, like a D major chord and an E major chord, and we would have a polychord. Now, these should clearly be voiced separately, so that you wouldn't hear that as a tall chord. So if I had a seventh in between there, that would just be heard as an extension of the D with a sharp 11 in it. So these are voiced as separate chords, and you would label both of those triads with a line separating them. So you have a bottom chord and a top chord. So here's again my E over D, and here's an E over C minor, F over B, and G flat over A. Now, depending on which types of triads you're combining, you can get different levels of dissonance, obviously, between those two chords. So related to the idea of polychords is polytonality in general, which involves music sounding in more than one key at the same time. Now, in practice, we generally only have two keys at once, so we would just say bitonality, two major or minor keys. Now, if both of those were modes, you would say bimodality. So if you had a Dorian mode and a Mixolydian mode being used, that would be bimodal. Here's an example. You can see there's two different key signatures here. The top hand is clearly in C major, whereas the bottom hand with 6 sharps appears to be in F sharp major. Right? So if I combine those together, I'd get something like this. Sort of clashy, because those two keys are quite distant from each other. Here's another example. Looks like the left hand is in G major, and the right hand is in B major, right? So we have G major and B major. These might not clash quite as much, but they'll still have some clashes. Okay, so there's two quick examples of polytonality. In this case, these are both bitonal. And that covers our lesson for today. So go ahead and take the quiz that follows.